At this point, we can talk about the concept of a random variable. And this is a concept that is widely misunderstood and maybe sometimes found hard to grasp. Um, Essentially, it's not random and it's not a variable. A random variable itself is not a variable. Essentially, it's a function. A random variable is a function from the event space to the real line. So what does this mean? This means a random variable is a function that assigns a numerical value to every possible event. For instance, consider the coin toss experiment. Here your outcomes are just heads and tails. So any assignment you make to heads and tails will form a random variable. For instance, if you assign the outcome of heads to 0 and tails to 1, this constitutes a random variable. Or if you assign -5 to heads and the number pi over 2 to tails, this is another random variable, okay? Or you can also assign the same value, if that makes sense for your application, to the same and to the both outcomes, and this will define a different random variable. So a random variable takes your outcomes and sort of enumerates them, right? So it's a way of expressing or enumerating the outcomes using just real numbers. So in this way, we take the outcomes and make them into numbers, so that we can define events in an easier way. Because when the outcomes are represented by real numbers, we are going to use the events in terms of equalities or inequalities or intervals. So it makes a definition of events easier. For instance, the probability of the random variable x1 being equal to 0 actually represents the outcome heads, or the random variable x1 being equal to 1 represents the outcome tails. Okay, so that is why these two events have the same 1/2 probability. Similarly, the value -5, x2 taking -5 represents the heads outcome, and x2 taking the value pi over 2 represents the tails outcome. Okay, so you get the idea. For instance, if you toss 3 coins, in this case you have 8 outcomes, let's say, if you consider the order significant, then you can assign each of these distinct 8 outcomes to a numerical value 0 through 7. They don't have to be consecutive, they don't have to be integers, they don't have to uh, equal spaced, but sometimes it makes sense to assign such random variables. Here our assignment is the integers from 0 up to 7 to each different set of outcome here. So y1 is simple enumeration, but it's not the only way to define a random variable on this random experiment. For instance, if I define y2 as 0 to 3 heads, 1 to this, 1 to this, 2 to this, etc., and this is another random variable. You see, I'm assigning the same value to multiple outcomes, but this is allowed because this is a function assigning numerical values to outcomes. So what could be the significance of this assignment? You see, it counts the number of tails. It's 0 here, 1, 1, 1 in these, just 1 tails. This one, and this one, you have 2, and this one has 3. If you are interested on only the number of tails or the number of heads, rather than y1, maybe you want to use y2. That's your choice. So depending on your application, you might choose one over the other. Let's see another one, y3. The first position, heads appear. Maybe that's what you are interested in, the first position, the first number of trial, you see heads. So 1, 1, 1, 1. This is 2 here because this is tails, but this is heads. And this is also 2. This one is 3. And this one is 0 because I don't see any heads here. That's my definition. Another one, length of the longest sequence. So that are repeated. So this is heads, heads, heads. So 3. I have a sequence of 3 heads. Here I have heads, heads, but then tails come. So 2, a sequence of length 2. This one, heads, tails, heads. So I don't have any sequence of 2 or 3. I just have 1. Here I have this tails, tails, so 2. Here I have heads, heads, so 2. Here again, all of them alternating, so 1. Here I have tails, tails, and here I have 3 tails, so 3. And finally, maybe you are interested in the number of changes in this outcome. Okay, so I have 0 changes here, also 0 changes here. Here I have just 1 change. I have 2 changes here. I have just 1 change here, and just 1 change here, 2 changes here, and just 1 change here. Okay, so depending on your application or the quantity that you would like to investigate, you can define the random variable however you like.